Good morning. Today we are working on our very last pre-algebra objective of the year. We are doing CO70. I can determine whether polygons are congruent, similar, or neither. So we have to know what those words mean and how to figure out if they fall under which category. Congruent polygons. What do we know about the word congruent? What does it mean, Gus?
Like equal size.
Equal. So if it's congruent polygons, goes to say that they are going to be equal. They are going to be the exact same. So a congruent polygon are polygons that are the same shape and any guess? Same shape and what if they are congruent? Close. I'm looking for a slightly different word. Super close. Going even simpler. Same shape and size. So their measurements, their angle measurements, their side measurements are all the same. Same shape, same size. So all sides and angles are congruent. So if we give ourselves a polygon that looks like this, and another polygon that looks like this, and we say this is A, B, C, D, we're going to call this X, Y, W, X, Y, Z. I can list the corresponding sides. I can say my side AB, so side AB equal to congruent with WX. This side is congruent with this side.
What's the little top on the equal sign?
It means that it's congruent with. So BC, and actually he put the little, oh, so it's congruent. So BC goes with XY, CD goes with YZ, and DA is congruent with ZW. So we can say these sides are the same measurement, these are the same, these two are the same, and these ones are the same, right? They are congruent, they are the same measure, they are the same size. So you always have to match up your sides. Sometimes you might have to flip or turn so you can match up the right side. Sometimes you might be given, let's say, a triangle like this, and we have to match it up with a triangle like that. You have to flip it so your short side matches up with your short side, right? So you always have to look, does it straight up match up with each other, or do I have to flip it to match up my short side with the short side? So congruent, they're identical, same shape, same size. Similar polygons. Any guess, Evelyn?
Is when it's the same shape and it's the same size, or the same size, not the right shape?
Has to be the same shape. So if it is a similar polygon, it is polygons that are the same shape, but
Different, like twisted, or like a different way.
no, the flips and turns, it's still identical for congruent. Doesn't matter if we have to flip or turn it. Yeah. Polygons, if it's similar, polygons that are the same shape but different size. So that means our angles are congruent. Congruent. And the sides, and this is important, sides are proportional. So they're getting bigger or smaller at the same rate. So it's the exact same shape. If they do not grow or shrink the same rate, the same proportion, they're going to be a different shape, slightly different. We need to make sure that they are proportional. Your short side is proportional to your short side. Long side is proportional to the long side. We need to make sure that it's growing. You multiply by 2, you multiply by 2, right? It's growing the same way. If they are not identical, we know they're not congruent. If the sides are not proportionate, then they are not similar. So they are neither. So we have congruent, similar, and neither. It's pretty easy to tell if they're congruent because the measurements will be identical. Right? So if the measurements are identical, we know it's congruent. The similar part is where we have to stop and think, and we have to do the math. With math, you can never, ever, ever look at shapes and look at angles and say, oh, they look to be the same, so they must be. Not with math. With math, you have to prove it. You have to do the work to say, look, I did the math and they got the same answer. So I can prove that it's similar. Okay, I can prove that they are proportionate. You cannot just eyeball it and say, well, it looks the same. Nope, we have to do the math. So I'm going to erase and scroll up so we can do some examples of proportionate. So, the corresponding sides, if they're similar, make equivalent fractions. So they're going up or going down at the same rate, multiplying by the same number, dividing by the same number each and every side. So if they are similar, so let's say this triangle, and we have this triangle, we said that our angles will be congruent. So if they give you angle measurements, each angle measurement matches up and are identical. They are equal to each other. Then we need to look at our sides. They don't always give us angle measurements. A lot of times they'll give us some sides. We need to look at those sides. Are they proportional? So I'm going to put some numbers on my sides. These are going to be some easy numbers for us to actually do mental math with. How am I going from 8, 14, and 18 to 4, 7, and 9? Gus? I divided each side on the large triangle by 2. Everyone was divided by 2. So if I drew my fractions, 8 matches up with 4, 14 matches up with 7, 18 matches up with 9. I'm going to divide it. 8 divided by 4 is 2. 14 divided by 7 is 2. 18 divided by 9 is 2. When I divide those fractions with one triangle side over the other corresponding triangle side, I get the same number. A lot of times it's going to be a decimal. A lot of times it's not going to be this easy where we can do the mental math. Oh, I'm dividing each one by 2. They're similar. Okay, that's the easy way. They're not. Mr. Schultz doesn't always give you the easy. Okay, so we're gonna see how we actually have to do that math for every side to see if every time we get the same answer. Here we got 2, 2, and 2, so we know that they are similar, they are proportionate. Over here it says list the pairs of corresponding sides. So I'm gonna label my points A, B, C, X, Y, Z. And because they are not congruent, I'm going to say AB is similar to XY. BC is similar to YZ. And CA is similar to ZX. Okay, so that squiggle means that they're similar. Doesn't have that equal sign under it, so they are not congruent. They're similar. It's sometimes with math that, like, just like for multiplying, we could have that or that. Okay. And actually, no, the two squiggle lines means it's an estimate. It's about something, it's an estimate. So this is different. The two squiggle lines means you're estimating, rounding. Okay, so we can say that side AB divided by side XY equals side BC divided by YZ, which equals side CA divided by ZX. Because we did our math, 8 over 4 equals 14 over 7, which equals 18 over 9. So we know that 2 equals 2 equals 2. They are proportionate. So when we are looking at our polygons, we are going to first look to see if they're congruent. Do they all have the exact same measurements? Woo, easy, easy peasy. Congruent, they're identical, same shape, same size. To look to see if they're similar, you have to do the math for every side. Because sometimes we'll have two sides that are proportionate, then the third side is not. So you have to check every side to see if they're all equal each other. If you take the top, divide by the bottom, does it equal the top divided by the bottom, the top divided by the bottom? And if this is polygon A and this is polygon B, you're going to put all the A's on top, all the B's on bottom, right? You have to match up your proportions. We've done proportions before. So this is math that we've done before. Now we're using it to find out if polygons are similar. But we've already worked on the proportions. So that part isn't new. We're just using it in a new way. So let's do this. Let's determine whether the polygons are congruent, similar, or neither. Explain how you know. Showing your work. Okay. Don't trust your eyes. The figures may not be drawn to scale. Always do the math. You can't just eyeball it and say, well, they look. Nope, you have to show the math. So if we look at our first set, let's look at this first set. We have 12, 15, and 9, 4, 5, and 3. Are they congruent?
No.
How do you know, Emily?
Because the sides don't match up properly.
They're not congruent. They're not identical sizes. So now we have to see, are they similar or neither? How do I do the math? What should I do, James J?
So you would divide it by.
Divide what? Mario, you had your hand go up. What do I do?
So you like match up the sides, so you put 12 over 4.
So this side matches up with this side, so 12 divided by 4. I'm going to say if it's similar, it's going to equal what?
3.
No, which sides? Because remember how we did this equals this equals this. 15 over 5. And does that equal 9 over 3? So this is one that we can do mental math on. There will be ones that you actually have to do the division, write down the decimal places, and the decimals must be equal. So this I can say 12 divided by 4 equals 15 divided by 3 equals 9 divided by 3. They all equal 3, so it is similar because they all equal 3. They are proportionate. They all shrunk down by 3. Let's look at our next one. Is it congruent? But I have 6 and I have 22 on top. Oh, this is one that I have to flip. I have to rotate it. Okay, so this 6 is short. It matches up with our short. So then opposite of it is our long. Opposite of this is our long. 22 and 22 match up. Look at my sides. Slanty 19, slanty 19, slanty 19, slanty 19. It's congruent because all the sides are congruent. So I'm going to label it congruent. And then it says explain how I know. I'm going to write all sides are congruent. All right, let's look at our second page. It does not want to erase for me today. There we go. All right. So at the top, it says draw and label each pair of figures. Make your figures as accurate as possible. So grab a piece of Lucy. So congruent, you need to draw two shapes that are congruent, so they have to look like what? Same shape, same size, and you have to label it. How can we label that? Tatum? You can put measurements. So you can say, okay, here's my triangles. I'm going to say 7, 7, 7, 7. Let's do this 8 and 8. So I can say, all right, I'm labeling it so I can see that all of my measurements are congruent. Do I have to write measurements to label it? Yeah, I could do my lines 7, 7, 7, 7, and my 8s match up. Or we know if they are congruent, all of the angles match up. So I could say this angle match up, and this angle matches up. Okay, so you're showing that the sides and the angles are all congruent. You either do it with your number measurements or you do it with the notches and the arcs that they're matching up. Now I need to draw similar. That means what? What does it mean if they're similar? How do I want to make them look? Mario? Proportionate. So same shape, different size. So I'm going to do a big, and I'm going to do a little. Same shape, different size. And I'm going to say if they're similar, I know that my angle measurements match. So I would say these angles are congruent, these angles are congruent. Okay, you're going to show that the angles are all congruent. You could write numbers to show that they're dividing down the same way. So you could say, this is 4, this is 2. And maybe this is 10s and 5s. So you could show it with your numbers that they are proportionate. You could show it that all the angle measurements are equal. Same shape, equal angles. Either way. How do I do neither? Evelyn?
Square and triangle.
Let's try to keep it the same polygon.
You could do 2 triangles and then
Like I could do 2 triangles, one that looks like that and one that looks like that. Obviously different triangle shapes. So it's the same polygon, but they're different. They look very different. This one looks like it might have a right angle. This one looks like it might be equilateral. So they have different measurements. You don't actually have to write the measurements, just make your shapes look very different. A square and a rectangle, they look very different. Both quadrilaterals, but there are different shapes of quadrilaterals. So this you need to know for the test, because you're probably going to be asked to draw these. Determine whether the polygons are congruent, similar, or neither. Explain how you know. Remember, do not trust your eyes. Do the math. So let's do the first one together so we remember how to do the math. How do I do this first one?
you do 19 divided by 12, 16 divided by 11, and 14 divided by 9.
And I need to see if that all equals each other. So, you do need your calculator for this, because I don't know 19 divided by 12 off the top of my head. I get 1.58. I like to round to that 100th place. You don't need to write it all out. This one I get 1.45. 14 divided by 9. I get 1.56. They are not equal. If they are not equal, you write neither. Showing your work is explaining how you know. So you can put that they are not the same decimal places. We see that. So you're going to write neither. You must write your fractions for each side lengths. Write the fractions. Write what you get to check to see if they are proportionate. If it is congruent, do we have to do that? No, because we can see the measurements are all the same. So that's how you know. If it is congruent, you say all the measurements are congruent. All sides are congruent. But in order to tell if it's neither or if it's similar, you have to write out your side proportions. Aiden did B over A, B over A, B over A. You could do A over B, A over B, A over B, and you would see that they're either proportionate or not proportionate. It doesn't matter which shape you put on top and which one you put on bottom, as long as you stay the same. B's are all on top, A's are all on bottom. A's all on top, B's all on bottom. The other thing that's important is that you're matching up your sides correctly. Okay, so make sure you might have to, I don't see that he has any flipped on here. If on the test one is flipped, you're going to have to flip it in your head so you're matching up the side to the correct side. Any question on today's work? Okay, if you are listening at home, we hope you are well. We hope to see you soon. Have a wonderful day.